Welcome to 2.4 video lesson Algebra 2. The concept is more about linear equations, and there are 6 boxes for us to talk about today. Okay, let's get right into it. Box number 1 is all about something called point-slope form. I'm pretty sure that you have seen this before, but most people are familiar with slope-intercept form, but I was going to talk a little bit about point-slope form. So you may recall that the slope formula is y2 minus y1 over x2 minus x1. And the way that this comes about is simply by adjusting the slope formula. So let's say that you only have 1 point instead of 2 points, y1 and x2 and y1 and x1. Let's just say you have 1 point. So let's say you're just given a point, an x1 and a y1. Let's say the y2s aren't there anymore. So then I would have m is equal to y minus y1 over x minus x1. So you're only given one single point, and x and y can be any other point in the whole coordinate or in the whole line. So if I multiply both sides by x minus x1 on both sides of this equation, x minus x1, you see that you get y minus y1 is equal to m times x minus x1. And that's exactly what point slope form is. So all this stuff right here is just the algebra to support where it comes from. The key thing to remember when you're dealing with point slope form is that you are given a single point and you are given a single slope for a line, and then all you have to do is put it into this form. So I'll explain a little bit more in the next box for you. Okay, here's box 2. It's an example, and let's say you're given the point -5, 2 and a slope of 3/5. I would like you to write an equation in point slope form. So let me show you how I would go about this. If it's asking me for point slope form, then I know I'm going to write down y minus y1 equals m times x minus x1. So this is the point slope standard form, and then this part right here, this is my x1. And this number right here, this is my y1. Of course, this is my slope. So I would have y minus 2 is equal to the slope of 3/5 times an x minus -5. Now you have to be careful and adjust your signs, but you get y minus 2. Y minus 2 is equal to 3/5 times the quantity of x plus 5. And that's all you have to do. You don't need to go any further because this is now in point slope form. Point slope form is a really convenient way to write the equation of a line, and it's often overlooked. So I'm glad that we're going to actually talk about it and use it. Okay, let me give you another example, and I want you to put the equation in point slope form, but in this particular case, you're not given the slope just yet. So what you have is 2 points. I'm going to call this x1 and y1, and x2 and y2. So the first thing we have to do is actually calculate the slope. We calculate the slope using the slope formula. So it's going to be y2 minus y1 over x2 minus x1, which in this case, y2 is a value of 8. Subtract y1, which is a value of 2. x2 is a value of 5. And then x1 is a value of 3. 8 minus 2 is 6. 5 minus 3 is 2. So 6 divided by 2 is a value of 3. So now I have the slope. Now, for point slope form, you can pick either equation. It doesn't matter which one you pick. So I'm going to go ahead and choose this one, but you could also choose the other one. It doesn't matter. So for point slope form, I'm going to have y minus y1 equals m times x minus x1. So I'd have y minus the value of 2, because that's my 2 right there, equals the slope, which I found earlier, which would be 3 in this case, times x minus 3, my value right there. So you can choose to use that one, or if you use the other point, it would be y minus 8 is equal to 3 times the quantity of x minus 5. Both of even though these look different, if you were to actually multiply these out and move to the other side, you come up with the same equation. But for point slope form, you can choose either one. Okay, box number 4 is another form of a line called standard form. So standard form looks like this. It looks like ax plus by is equal to c. So it's not point slope form, and it's not slope intercept form. It's what we call standard form. A couple of things that you have to remember for standard form. The a value and the b value, meaning this thing right here and this thing right here, they can't both be 0. Because if they were 0, then all you'd have is 0 equals some other constant c, and that's not really a line. So they can't both be 0 at the same time. And then all of them, the A, the B, and the C, meaning this number, and this number, they all have to be real numbers. That's what that symbol means right there. So those are the two things you have to consider. Both A and B can't be 0 at the same time, and all A, B, and C need to be elements of the real numbers, which means they can't be imaginary numbers. Okay, so let's do a little quick example here. Let's write y equals 3/4 x minus 5 in standard form. So we want to put it in standard form, so it needs to look like this. And we want to use integer coefficients. So integer coefficients, you'll remember, are like all of the negative integers, like -1, -2, -3, the number 0, and then of course 1, 2, 3, and 4. 5.6 is not an integer. 3/2 is not an integer, right? So it has to be integer coefficients only. So here we go. I'll do this in green for you to make it a little bit different. So if I start with y is equal to 3/4 x minus 5, I would multiply the entire thing by 4 to clear my fraction. So I would get 4y is equal to 3x minus 20. And then I'm going to come over here for you. Then I would move the 3x to the other side. So I would get 4y minus 3x is equal to negative 20. And I can stop. Here's why. I have the value of A is 4, the value of B is negative 3, and the value of C is negative 20. Those are all real numbers and they are all integers. So therefore, I have done the problem correctly and it's asked me to put it in integer coefficients. So 4y minus 3x equals negative 20. Okay, box 5, let's talk quickly about the basics of parallel and perpendicular lines. This should be a review for you. But here we go. On the left-hand side, I have parallel lines. On the right-hand side, I have perpendicular lines. So the thing to remember about parallel lines is that the slope of the first line is going to equal the slope of the second line. But you'll notice that where they intercept on the y-axis, the b value, so b1 is not going to be equal to b2, meaning that their y-intercepts are going to be different. So parallel lines, of course, they have the same slope, but they have different y-intercepts. Perpendicular lines, you'll notice that they meet, the whole point is that they meet at a right angle. And if you multiply the product of their slopes, so if I take the slope of M1 and I take the slope of the second line, it's going to equal -1. So the product of their two slopes has to be a value of -1. The other way to think about this is that they are opposite reciprocals of each other. So as an example, let's say if this has a slope of 1, 2, 3 over 1, so this line has a slope of 3, then this line would have to be the opposite and the reciprocal. So this slope would have to be -1/3. And then of course, when you multiply those together, 3 and a -1/3, you'll notice you get -1. So it matches that definition down there. I don't think this is new for anybody, but it is a good review for us. Okay, box number 6 is a U-try. Let's say this, a line passes through the point 2, -1 with a slope of 3. What is the equation of the line in point slope form? And I gave you a reminder that this is what point slope form is. Okay, good luck. Okay, hopefully you got the right answer of y plus 1 is equal to 3 times an x minus 2. So how did I do that? First, I wrote down the slope intercept form, which I gave to you right up here. Then I wrote down the problems, or the part that I knew, y minus y1. y1 is a value of -1, equals the slope of 3 times x minus x1, which is a value of 2. I changed the signs, y minus -1 to give me a y plus 1. And there you go.